What are the two algorithms that we discussed in the second unit, or what is second unit all about? I hope the PPT is visible to everyone. Is it visible? Can somebody respond, please?
Yes, ma'am.
Okay, right. So second unit was all about association rule mining. Okay, so in association rule mining, we discussed two algorithms. Mm. So there are basically two types of algorithm. One is frequent pattern mining with candidate generation, wherein we discussed about a priori algorithm. The second is frequent pattern mining without candidate generation. Okay, so that's where we discussed about FP growth algorithm, frequent pattern growth algorithm. Okay, so do you remember what was the difference between this a priori and FP growth? Can somebody tell me the difference between a priori and FP growth? Hiten, can you tell me what's the difference? Hiten, Achinta?
Ma'am, yes, ma'am.
Yeah, can you please tell me, do you know what is the difference between a priori algorithm and FP growth algorithm?
Ma'am, in FP growth algorithm, we actually like arranged in descending order of support count, whereas in this in a priori we arranged it in ascending order.
You were listening to something, but then I think you were sleeping off in the class. Okay, at least you made an attempt. So let me tell you clearly what is the difference between FP growth and a priori. Okay, so in a priori algorithm, like at each step, the candidate set has to be built. Okay, so the algorithm had to repeatedly scan the database. Okay, so all the item sets of the transaction need to be generated, and generating all the item set is a very complex task. Okay, and in many a times, many of those item sets may not be even frequent. Okay, so whereas in FP growth, you are generating item sets that are only frequent. Okay, so it is an enhancement of an a priori algorithm. Okay, so in let me tell you once more clearly. So a priori algorithm will be scanning the entire database multiple times. So I mean, you can say you need more resources then. Okay, so to generate the association rules. Okay, so because with the increase in database size, you need to scan the database multiple times. Okay, whereas on the other hand, your FP growth algorithm that will not scan the whole database multiple times. Okay, so it is considered to be much more faster when compared to the a priori algorithm. Okay, so that's what in FP growth you are generating the item sets that are frequent only. Okay, whereas in a priori algorithm, all the item sets of the transaction needs to be generated. Okay, so that's the primary difference between your FP growth and a priori. So FP growth is considered to be a little more faster. Okay, so now I have shown a slide out here, which is an exercise for FP growth. I want all of you to note it down, and by the time I take attendance, you are expected to be doing this. Okay, I know many students were absent for the special class which I took last week, where I explained the FP growth. Okay, so like you just take the help of those who have done the, I mean, attended the class and or whatever. So I have, I hope you can see the transaction database out here. Okay, there are 9 transactions mentioned out here. So this is are all some list of items in each transaction. Okay, A stands for asparagus, C for corn, B for beans, T for tomato, and S for squash. So the short forms are given here. So in each transaction, what are the list of items which are being bought? Okay, so can somebody quickly recollect what exactly do we are supposed to do in FP growth? What is the first step? So FP growth is all about, first step you need to construct what is called a frequent pattern tree. So for FP tree, then in the second step you need to construct what is called a conditional pattern base. Okay, so for that purpose, for the first step, what you do is you first uh, arrange your transaction database in the descending order of your support count. See, these are the two steps, what we discussed in the previous class, FP tree construction and conditional database construction. Okay, so first you need to scan the entire database. Okay, something similar to your a priori. Then the second step is you need to construct the FP tree. Okay, so the root will be represented by null. Okay, then you examine the transaction and find the item set in the database. Okay, the one with the maximum support count will be at the top of the item set. The one with the lower count will be taken at the bottom, and so on. Okay, so that's the reason why we arrange the transactions in the descending order of the support count. Okay, so this is what Hiten was telling about. I think one of the person who have tried was telling about. Okay, the next step is you need to examine the transaction database. Then the item sets are sorted in the descending order of the count. So if any item of the transaction is already present in any other branch, then this transaction branch may share a common prefix to the root of the FP growth algorithm. So that means the common item set is connected to the new node of another item set in this particular transaction. Okay, after that, you count the item set. Next step is that the count of the item set is increased. Then the common nodes, in case there are common nodes, then the existing nodes count is being incremented by 1 and they are linked according to the transaction. Okay, so the next step is what you do is you start mining the FP tree. Okay, so start mining the FP tree. What do you mean by mining the FP tree? FP tree mining process. Okay, so what you basically do is you start with the item with the least support count, that is length 1 pattern. Then you construct what is called a conditional pattern base. Okay, then you construct the conditional FP tree and perform the mining recursively on the tree. Okay, so that's how you get the frequent patterns are getting generated. Okay, so that's the gist of the algorithm. So this is the problem what we discussed. I mean, we worked out in the previous class. This is your FP tree, your conditional pattern base, and this was the exercise what we did. So now today's class you do this exercise. Okay, so when I take attendance, I want all of you to be doing this exercise. Hope all of you are listening. Okay, so now let me take the attendance.
Ma'am?
Yeah, tell me.
Ma'am, what's the minimum support count for this question, ma'am?
That I think it's not mentioned. You can take it as 2. You can take it as 2. Minimum support count is taken as 2. I think I didn't mention it here. You can take it as 2. Minimum support count is 2. Okay, now start answering your attendance. Anirudh,
Present, ma'am.
Dharani,
Present, ma'am.
Ram Harini,
Present, ma'am.
Kalyan Sundar,
Present, ma'am.
Aravind,
Present, ma'am.
Sharan Varghese,
Present, ma'am.
Shakti Priya,
Present, ma'am.
Nishok. Nishok is absent. I'll project the first step out here. Okay, no need, otherwise fine. So Nishok is absent. 24, Shreya.
Present, ma'am.
30.
Present, ma'am.
Yeah. What about 30? Suvetha,
Present, ma'am.
Vishal Bhashyam. 33. Anybody putting in the chat window or anything? Let me know. Okay, so Vishal Bhashyam is also absent.
Ma'am, present,
Yeah?
ma'am. Ma'am.
Vishal Bhashyam is present. Okay, noted.
Yes, ma'am. Sorry, ma'am. I
35,
just
yeah.
now joined.
No problem. M. Srimati, 35.
Present, ma'am.
Ma'am, 23 present, ma'am. Just now joined, ma'am.
Okay, noted. So 37,
Yes, ma'am.
41 Pranav Ram,
Present, ma'am.
Srimati,
Yes, ma'am.
46. Yeah, Raja Singh,
Present, ma'am.
Pooja,
Yes, ma'am.
Lavanya,
Present, ma'am.
Nityashri,
Present, ma'am.
59 Sriram. Okay,
Chat
noted.
box.
Noted. Fine. Next is Likita, 27.
Present, ma'am.
Satyamohan.
Present, ma'am.
Sharan. Yes, sir, Sharan. 63. 63 is absent. Okay, 63 is absent. Agral Patel, 67.
Chat box, ma'am.
Okay, noted. Hemavartini,
Present, ma'am.
Ajay,
Present, ma'am.
Akshata Saha,
Present, ma'am.
Karthik Balaji,
Present, ma'am.
Santosh Kumar,
Yes, ma'am.
Anand Arun. Okay, noted. Noted. Rahul P, 116. Okay, noted. 117, Suhasini Srikanth,
Present, ma'am.
Apurva Ravichandran,
Present, ma'am.
Mithun,
Present, ma'am.
Adityan,
Present, ma'am.
Selva Niklesh,
Present, ma'am.
Ram Sharan,
Present, ma'am.
Achinta Murari,
Present, ma'am.
Santosh Kumar, 145.
Present, ma'am.
147, Pavitra Shri,
Present, ma'am.
149, Praveen,
Present, ma'am.
Rakesh, 171. Rakesh is absent. No response. Okay, Nitya Sri Narasimhan,
Present, ma'am.
Nisho Katraven,
Present, ma'am.
Abel Prashant, Abel, 25 is absent. Okay, 28, Pritika,
Present, ma'am.
40, Kevin Kurian Joseph, okay, 45, yeah, Adya,
51, present, ma'am.
53, Jay Vora,
Yes, ma'am.
Kishore,
Present, ma'am.
Sridevi,
Present, ma'am.
Yash Rai, 62. Yash Rai, no response. 70, Jayesh Kumar. Jayesh Kumar also no response. Anybody missed?
Jayesh, present, ma'am.
Jayesh is 70. 70 is present. 62 is absent, right? Okay, so anybody missed the attendance? No. Okay. Okay, so let's see how far you've progressed with the problem.
Ma'am, 171 chat box, ma'am.
171. huh? 171. Okay, 171 noted. But 25, 62 and all from C section is absent, right? Okay. Right. So let's see how far you have progressed with the problem. Okay. Right. So first, what you did is, what you're supposed to be doing is, you need to create a table of item counts from the transactional database. Okay. So you write the count for each item. You write the count for each item. This you would have already done. And then the next step is you arrange them in the descending order of your support count. Okay, so as per this, asparagus will come first, then followed by beans, squash, corn, and tomatoes. Okay, so that's his next step. After that, what are you supposed to be doing? You start with your FP tree construction. You start with your FP tree construction. So the root will be represented by null. Okay, then you take the first transaction. What is the first transaction? BAT. BAT. So you arrange the transactions in the descending order of your support count. So when you arrange the transaction in the descending order of your support count, it becomes ABT. Okay, ABT, because A is 7, B is 6, and T is 2. Okay, so from the so you represent in the same order, that is in the descending order of your support count. First should be A. So A from the root with a count of 1, followed by B should be linked to A, and T should be linked to B. Okay, each with a count of 1 each. Okay, so the first transaction is being scanned. So now coming to the second transaction. What is the second transaction? AC. So here you need not reorder. It's in the same order as the descending order of your support count. Okay, AC. Okay, so already A, there is a link from the root. So you increase the count of A to 2, and then is there a link from A to C? No. So you create a new link or a new node. So C is being created with a count of 1. So second transaction is being scanned. Now coming to the third transaction. It is AS. It is in the same order. Okay. So A already link is there from the root node. So you increase the count to 3. Then S, you don't have a link from A. So you create a link and S, you put it as 1. Okay, so that's the third transaction, AS. So next, coming to the fourth transaction. Fourth transaction is BAC. Okay, fourth transaction is BAC. I hope I'm audible clearly. Okay, so fourth transaction is ABC. Fourth transaction is BAC. You arrange it in the descending order of the support count. It becomes ABC. So the count of A becomes 4. Then there is a link B already from A. So you increase the support count to 2. Then there is no link from B to C. So you create a link and create a new node C with a count 1. So transaction 4 is over. Okay, so next moving on to okay, so next moving on to transaction 5. Okay, transaction 5 is BS. Okay, BS from, yeah, so you create it accordingly. So from root, you don't have, yeah, this is BS, this becomes 2 and S becomes 1. You don't have a link, sorry, not this. This is transaction 5. So this one to the right hand side. Okay, so from root, you don't have a link to item set B. So you create a link to the right hand side with a frequency count 1. Then the next is S. Okay, so from B, you create the new node S. Okay, so this is BS, transaction 5. Okay, so next is transaction 6. Okay, so transaction 6. So transaction 6 is AS. Okay, AS. So A already, the count was 4 in the previous case. You would have seen 4. So now it's getting incremented to 5. Okay, then already your S was there. So that gets incremented to 2. Okay, that is the 6th transaction. Okay, so now coming to the 7th transaction, it is BS. Okay, so B already, it was 1. So now it got incremented to 2. On the right hand side, you can see. Then S, previously it was 1. So there is a link from B to S. So as a result, count gets incremented to 2. So that is the 7th transaction. Now coming to the 8th transaction, it is BAST. Okay, BAST. So when you are arranging it in the decreasing order of the support count, it becomes ABST. Okay, so A becomes 6, B becomes 3, S. So there is no link from B to S. So you create a new link or a new node S with a count 1. And from S, you have another link called T with a count 1. Okay, so that is T8, transaction 8. So next coming to transaction 9. The transaction 9 is BAS. So when you're arranging in the decreasing order of the support count, it becomes ABS. Okay, so A becomes 7. Okay, then B becomes 4, then S becomes 2. Okay, so this is your final FP tree, the final FP tree. I hope you have understood regarding the FP tree construction. Okay, so arrange the support counts in the decreasing order of their, arrange the transactions in the decreasing order of the support count, and then start constructing the FP tree starting with the item from the first transaction, and start linking them to the root according to their support count. The one with the maximum support count will be getting straight linked to the root, and the remaining will be coming as the lower nodes. Okay, then scan in the entire database and construct the FP tree. Okay, so now this is the FP tree. This is with all the links. Okay, the FP tree with all the links. You can see asparagus, the link with the support count 7. So you can see here 7. Then if you see beans is having a support count of 6. So where do I get 6? So out here I'm having B as 4, then another B as 2. So 4 plus 2 is 6. So you can cross verify. Okay, same way squash. Squash is also having 6, support count of 6. So 2 plus 2 plus 2 becomes 6. So you can verify that. Okay, so corn is 2. So 1 is here, 1 is here. So 1 plus 1 becomes 2. Okay, tomato is 2. Tomato 1 is here, the link is here, another one is here. So 1 plus 1 is 2. Okay, so now constructing the conditional pattern base. Okay, so how do you construct the conditional pattern base? How do you start? Why did you take tomato first here as the first item? Can somebody tell me? Why did I take tomato as the first item? Yeah.
Least support count.
Yes, very good. I start with the item with the least support count. Okay, start with the item with the least support count. Then you see in your condition, in your FP tree, for tomato, how do I reach the T starting from the root of the tree? Okay, so one way is this, that is from root you go to A, B. Okay, A, B, you reach T. Okay, that is the first one. A, B, I reach T with, and what is the count written against T? It is 1. So it is the same one that I write here. Okay, so which is the other path? The other path to reach T is A, B, S. Okay, A, B, S, and then you reach T. Okay, here also count of T is 1. So that's what I have written here, conditional pattern base. Okay, so now I prepare my conditional FP tree. Okay, so what are the common items here? A and B are the common items here. Okay, so A count is here 1, A count is here 1. So 1 plus 1, it becomes 2. Here, which is the second common item here? Second common item is B, which has got a count 1 here and 1 here. So it becomes 2. So these are the 2 common items in your conditional pattern base. Okay, then from this conditional FP tree, you generate the frequent patterns by combining it with the source item. Okay, so what is the source item? Tomato. Okay, so these are the various patterns which are being generated: A, T, or BT, or ABT, all with a count of 2. Okay, so that's what. Next is corn. So how do you reach corn here? Okay, how do you reach corn here? So one is you can straight A. A you can from A you can straight away reach C. The other one is A, B, C. Okay, these are the 2 ways in which you can traverse to corn. Okay, so that's what is mentioned here. A, B with the count 1, A with the count 1. So consider the common items here. What are the common item? A is the only common item. So 1 plus 1, it becomes 2. Okay, then join with the source item. What is the source item? Your corn. Okay, join with that to form the frequent pattern. Similarly, you prepare for squash and beans. Okay, squash and beans, and you generate the frequent patterns. Okay, so this is how the frequent patterns are getting generated. Okay, so what is the outcome of this? You're having these frequent patterns. Okay, so what frequent pattern? This is a 2-item frequent pattern. Okay, 2-item frequent pattern set. AC2. Okay, whereas if you see this is a 3-item frequent pattern set. Okay, 3-item frequent pattern set, your ABT. Okay, ABT, this is a 3-item frequent pattern set. Then ABS2, this is also a 3-item frequent pattern set. Same way you have 2-item frequent pattern sets. What are the 2-item frequent pattern sets here? AT2, BT2, then AC2, okay, AS4, BS4, okay, AB4. Okay, so we have arrived at distinct sets. Okay, so none of the sets are similar in the case. Okay, so when you're comparing with your a priori algorithm, we have generated only the frequent patterns in the item sets rather than all the combinations of different items. Okay, so for example, here we haven't generated, let's say, tomato and squash, that is T and S. Do we have such a combination? T and S? No, we don't have. In a priori, we would have generated that and then later we would have ignored or eliminated. So that we are not doing here. So we are saving the time in the case of FP tree algorithm. Or another combination, corn and beans, C and B. Do we have that? Because we are generating only the frequent patterns. So these are things, they are not frequently bought together. Okay, so actually that is the main idea behind all these association rule mining criteria and FP growth algorithm and other things. Okay, so that's main concept behind your FP tree algorithm. I hope it's clear now. Is it clear now? Were you all following or sleeping in the class? Hiten, following?
Following.
Apurva? Apurva has left the class, huh? Okay.
Mom,
Fine.
yes, mom, I'm there.
Okay, right. So these are the benefits. Benefits already I have told you. Preserving the complete information. Never break a long pattern of any transaction. It's compact. You're reducing all the irrelevant information. That is, infrequent items are gone. You're not taking that into consideration. Okay, so that's what I have explained all these things. This is the performance of FP growth versus a priori. Okay, so now coming to the all what I have told so far is being put as a thing. Okay, these are the various papers and works which are being done. Okay, so next, moving on to the next algorithm. Okay, so far whatever we have discussed, your a priori and the FP growth. FP growth, this one, the first, and FP growth. So they are all working on horizontal data sets. Okay, so now we will look into a algorithm which will consider or take into consideration vertical data format. Okay, vertical data format. Frequent pattern mining with vertical data format. Okay, so I hope whatever we have discussed so far is clear. We discussed about a priori. Then what were the techniques for improving the a priori algorithm, like database partitioning and various other techniques, 2-3 other techniques, dynamic item set counting, and 2-3 techniques was discussed for improving the efficiency of a priori. Then we also discussed a algorithm called FP growth, which was considered to be more faster when compared to your a priori. So next, moving on to frequent pattern mining with vertical data format. Okay, vertical data format. So first, coming to what basically is a vertical data format. Okay, so these are the two commonly used formats. Okay, among these two, the most commonly used format is horizontal data format. Okay, horizontal data format is what is being shown in the first table here. Okay, where you have the transaction ID, also called the TID, and what are all the list of items occurring in the transaction. For example, in transaction T10, Coke, Slice, and Kurkure is being bought together in this particular transaction. Whereas in transaction 20, Coke and Kurkure is being bought together. Okay, so the pattern is TID, TID colon item set. Okay, so that is what the horizontal data format is all about. Okay, horizontal data format. Transaction ID colon item set in flower brackets. Okay, so the second one, the table what is being shown down here. So that's another commonly used data layout. It is called the vertical data layout. Vertical data layout. So you can see here. Here the item sets. Item sets are being shown in separate rows, and for each item they are occurring in which transaction. For example, Coke is coming in transaction T10 and T20. Coke appears in transaction T10 and T20. Slice occurs in transaction T10 and T30. Kurkure occurs in transaction T10 and T20, whereas pizza occurs in transaction T30. So here the format is items, item sets, colon, transaction ID. Okay, or TID set. Okay, TID sets, set or sets. It could be more than one transaction. It need not be one transaction. Okay, so your a priori algorithm, what we discussed, uses your horizontal data format. Okay, so your FP growth algorithm, those are all algorithms which makes use of your horizontal data format. Okay, so now we are going to discuss another algorithm called, let me see equivalence class transformation algorithm, ECLAT algorithm, which makes use of what is called your vertical data format. Okay, so actually this vertical, the algorithms which work on this vertical data formats are considered to be much more faster when compared to the algorithms which deal with your horizontal data formats. Okay, but then vertical data format also has its own set of disadvantage, because when the intermediate results of your vertical transaction IDs, they become too large, it may not fit in the memory. Okay, so that can affect the algorithm scalability. Okay, so that's another disadvantage of it. But then generally the algorithms that deal with vertical data formats are considered to be much more faster when compared to the ones which work with horizontal data format. Horizontal data format means your a priori algorithm. Okay, so it's something like imitating your the so-called breadth first search, BFS, whereas your the algorithm what we're going to discuss right now, it's called ECLAT. Okay, ECLAT will be imitating your DFS, depth first search. Okay, so generally you say DFS is more faster when compared to your BFS. So the same logic out here also. Okay, so you have a vertical transaction representation, whatever I just showed you just now, a vertical transaction representation. So there is no subset test or no subset generation is needed in order to compute the support. Okay, so generally the transaction IDs, TIDs, so TID sets are used to calculate your value of your support count. Okay, so so you can, some overview of the algorithm is given here. So both your a priori and FP growth uses horizontal data format, whereas ECLAT mines frequent item sets using the vertical data format. Okay, so it is a DFS based algorithm. Okay, so in this, what happened? Okay, so each item is stored together with its transaction ID. So the main point out here, the last point, okay, it uses a intersection based approach to compute the support of an item set. I'll tell you what this intersection based approach is. Okay, intersection based approach, you can see here, this is what is meant by intersection based approach. Okay, so you're calculating the support count for an item set by intersecting the transaction IDs of two of its k-1 subset. Okay, so A intersection B, you can see here. What is this output depicting? Which are the items which are common in both A and B? So 1 is common in both A and B. Then 5 is common in both A and B. 7 is also common and 8 is also common. Okay, so the common item sets. Okay, so because of this, you can say that you can have support for fast frequency counting. Okay, you can count the frequencies much faster through this intersection operation on the transaction IDs, TIDs. And you can say it is automatically pruning or eliminating the irrelevant data. Okay, so these are all the advantages. But then if the data set is very huge, again, you have so many intermediate results for your vertical TIDs, then it might become too large to fit in the memory. So that can also affect the algorithm scalability, what I just mentioned 2 minutes back. Okay, so but then generally these kind of algorithms are considered to be much faster when compared to your a priori and FP growth. Okay, so now I'll explain with an example. Okay, so this is the overview of what the algorithm is all about. So rather than discussing this step first, we'll first work out an example, then we'll come back to the steps. Then it will be easy for you to follow. Okay, so let's take this. So I want all of you to note it down in your notebook. Okay, 9 transactions. Okay, so initially what format is this? This is a horizontal data format, the usual format what we were following in your a priori algorithm or FP growth algorithm. The set of transaction IDs followed by the list of items in each transactions. Okay, so the minimum support count is given as 2 and confidence is given as 70. The question is generate the association rules using ECLAT algorithm, ECLAT algorithm, equivalence class transformation algorithm. So what could be the first step from what I have discussed so far? Common sense should tell you that. What should be the first step?
Converting into vertical.
Very good, very good. So first step is I need to convert this horizontal data set into a vertical data set, vertical data format. Okay, so horizontal format is all about TID followed by list of item. So the other one is, yeah, you have the list of items. You are converting it into this format. Okay, item sets and transaction TID sets. Okay, you can name this as TID, list of items. Rather than that will be more confusing. So I cannot change now because it is an image. You can put it as TIDs, transaction IDs. Okay, so item 1. Item 1 is appearing in transaction 1, transaction 4, transaction 5, transaction 7, transaction 8, and transaction 9. Okay, so instead of the count of items, you are required to mention in which transactions it is appearing. For example, I2. I2 is appearing in transaction T1, T2, T3, T4, T6, T8, and T9. Okay, similarly for all the other items. Okay, so what is our minimum support count? Minimum support count mentioned in the question is 2. Okay, minimum support count mentioned in the question is 2. Okay, so are all the item sets satisfying the criteria, minimum support count? See, the items are all appearing in minimum 2 transactions. Even there are I4 is coming in 2 transactions. If it was coming in only 1 transaction, then straight away we could have eliminated I4. But then all the items are coming in minimum 2 transactions. So all the item sets are qualifying for the next round. It is satisfying the minimum support criterion. Okay, so items are all appearing in minimum 2 transactions. So all the items qualify. Okay, so this is the first step. Okay, so next, moving on to the next step. So you're generating 2 item sets from your 1 item set, something similar to your a priori algorithm. Okay, so we need to take the combination of items. Okay, so combination of items. Okay, I1 to I2, I1 to I2, or I1 to I3, or I1 to I4, I1 to I5. Okay, similarly, I2 to other items, I2 to I3, I2 to I4, I2 to I5, then I3, I3 to I4, I3 to I5, I4 to I5. Okay, so when we take this I1 to I2, when we take this I1 to I2, how do we do that? I1 to I2. We will have to use our intersection concept. Intersection concept is what I have told you here. See, the items which are coming commonly in I1 and I2. So that alone will come here. So that intersection concept has to be taken into consideration here. Okay, so which are the items common in I1 and I2? Okay, that's what is written here. Okay, what are the items common in both? Okay, what are the items common in both I1 and I2? It is T1 is common, then T4 is common, then T8 is common, and T9 is common. That's what is written here. Okay, so in all these 4 transactions, I1 and I2 appears. Okay, that's what is mentioned here. Okay, similarly, find the list of items for this 2 item set by making use of the intersection concept. Okay, so after doing that, you will land up with this particular table. Okay, so now what has to be done, or what can be done? What is the minimum support count? Minimum support count is 2. Are all the two items combination set satisfying the minimum support criteria? Is it satisfying? Are all combinations satisfying the minimum support criteria?
No, ma'am.
No. Which is not satisfying? I1, I4. See, I1, I4 is having only one transaction. It's appearing in only one transaction, T4. So I can remove this. Okay, same way. I3, I4. There are no items in that category. Or I3, I5. Only it is coming only in transaction T8. Okay, then I4, I5. Okay, so I can remove all these. Okay, so 1, 2, 3, 4 transaction, 4 item set combinations I can remove. See, I am removing this. Okay, so with the minimum support criteria, I am eliminating the 4 item set combinations. So now my new set is this. Okay. Then what should be the next step? So next step is you need to generate 3 item set. 3 item set from 2 item set. Generate 3 item set from 2 item set. So what do you get? Try doing on your own. Are you all doing or simply staring at the screen and sitting? Mithun, listening? Is
Yes,
there a
ma'am. Yes, ma'am. Yes, ma'am.
Okay, please. Please work it out. I'll definitely be asking a problem for the second cycle test from all these algorithms. Okay. You please mute your microphones. You're deafening my ears. Okay. So generate 3 item set from the 2 item set combination. Okay. So the various combinations. Like you are trying to make use of, we had learned the join and prune property of your a priori. Okay. So 3 combinations are possible with I1. 3 combinations. You can see here. I1, I2, I1, I3, I1, I5. So there are 3 combinations. Okay. So, I mean, I1 is common in all the 3. Okay. Because I1 and I2 you cannot combine. We don't combine I1, I2 because the first element should be common when we combine the items. Okay. So you have all these. Okay. So this I1 and I2 you cannot combine. Okay, the first element should be common in all the whenever you combine. Okay, so based on that you get this. Okay, I1, I2, I3 and I1, I2 and I5. Okay, the remaining things whatever I have marked in red do not satisfy the minimum support count. So I am eliminating them. Okay, so after elimination I get this. Okay, so the point to be noted is when you're combining the first 2 items, when we try to generate the next one, that is a 4 item set combination. 4 item set, the first 2 items must be common. Only then you go for combining. Okay, so when you combine and make it as a 4 item set, it appears only in transaction 8, T8. Okay, so T8 means what happens? It is not satisfying the minimum support count. Okay, so the table with 4 item set is null. Okay, so we are stopping our algorithm. Okay, so we need to stop with the last step was this one. I1, I2, I3, which is appearing in T8 and T9, and I1, I2, I5, which is appearing in T1 and T8. Okay, so now we can frame rules or we can generate rules from these 3 item sets. Okay, the first and the second. Okay, so you can take anything. You can generate rules from the first one, that is I1, I2, I3, or from I1, I2, I5. Okay, so out here I have illustrated by expanding the second one, that is I1, I2, and I5. The second one. Okay, the first one can also be taken. Here I've just taken I1, I2, I5 for illustration purpose. Okay, so what are the various rules which are possible, which can be generated from this? Okay, I1 and I2 giving I5. I1 and I5 giving I2. These are the various, the 6 combinations. Okay, the various 6 combinations. Okay, so for these combinations, you compute the confidence. What is confidence? Can somebody confidently tell me what is confidence? Confidence, what is confidence? Confidence to answer in the class. What is confidence here in association rule mining? The class is so silent. Anirudh, at least I hope you two, at least you are listening. Anirudh, what is confidence?
Yes, ma'am.
The possibility that the customers are buying two things together. For example, if it's biscuit and chocolate, the possibility that the customer is buying the two things together. How do you compute the confidence? Confidence of A implies B. Support count of A union B divided by the support count of A. I hope you remember, we had discussed in the first class. Or confidence, you can say frequency of A comma B divided by the frequency of A. All these formulas we had discussed. Okay, so if a rule satisfies both your minimum support count and minimum confidence, then we call it as a strong rule. Okay, then we call it as a strong rule. Okay, for us in the question, it is given that the confidence is 70%. Okay, so now when I calculate the confidence, okay, the second rule, the third rule, and the sixth rule is having a confidence of 100%. Okay, the remaining rules are not satisfying the minimum confidence criteria. Minimum confidence criteria is 70. So this is having only a confidence of 50%. The fourth rule is having 33% confidence. The fifth rule is having 29% confidence. Okay, so they can be eliminated. Okay, so they can be eliminated. Okay, so I have put 3 rules in red color band. What does that mean? 100% confidence means what? What does that indicate? People who are purchasing, say, let's say the second rule, I1 and I5 implies I2. What does that mean? What it means is when people are purchasing I2 and I5, they are also purchasing I2. When people are purchasing bread and milk, they are also purchasing butter. So I can say I1 is bread, I5 is milk, I2 is butter. Okay, so that's what. What is the third rule telling you? When people are purchasing I2 and I5, they are also purchasing I1. Okay, or what does the sixth rule tell you? When I1 and I2 are bought, definitely I5 is also bought. Or when I5 is bought, I1 and I2 are bought in combination. Okay, so that's what it tells you. Are you all following, listening, or sleeping?
Following.
Yes, ma'am.
Listening. Okay, fine. So that's what your ECLAT algorithm is all about. By mining, exploring the vertical data format. And again, the point to be noted is ECLAT cannot work on horizontal data formats. You need to convert the data into vertical data format, and only then you can work on it. Okay, so what basically you did is, in the first call of the function, all the single items or data are used along with their respective transaction ID sets. Then the function is called recursively. In each recursive call, each item in the TID set pair is verified and combined with the other item in the TID sets pair. Okay, so this process is repeated until no candidate item set can be combined. Okay, so that's what. So that's what your ECLAT algorithm is all about. Now I'll give you an exercise. Please work it out. Do this. So here I'm giving, there are 4 transactions given in the horizontal data format. 4 transactions given in the horizontal data format. T1, the list of items are K, A, D, and B. T2, D, A, C, E, and B. T3, C, A, B, and E. T4, B, comma, A, comma, D. Okay, I'm telling the minimum support count is 60%. The confidence is 80%. And you are supposed to generate association rules using ECLAT algorithm. Can you start? The class is up to 2:10, na?
Yes, ma'am.
Okay, so can somebody take a snapshot of this and put it in the WhatsApp group and work it out and come in tomorrow's class? Class representative Selva, please take a snapshot of this and post in your WhatsApp group. Selva is there or join for the next class? Selva's gone. Okay, so can somebody do that? Anirudh, can you do that?
I shall do that. I shall do that.
Yeah. Take a snapshot of this, post in your WhatsApp group. So tomorrow I'll be randomly asking somebody to give me the answer for it. Yeah. Please take a snapshot of this and put it in the WhatsApp group. So with that, I'm winding up the class. So we have discussed 3 algorithms so far. And regarding tomorrow, so tomorrow we have this guest lecture in the first hour. So join on time. So your attendance will be with respect